Okay, well, we're coming to the end of the automation series here. Only got really 3 more sensor suites that I have to put together, and I spent the last few days designing them electronically in the computer-aided design tools. So this little packet of paper right here, 19 pages of definition of both of the 2 sensor suites that I have to make. There's 2 sensor suites. One of them I have to make 2 of for a total of 3 different sensor packages that I have to put together. So I'm going to cut over, show you the electronic version of this here real fast. Here we are within my systems modeling program. This is called Enterprise Architect is the name of the tool, and what we're looking at right now is a block diagram of the 2 electrical or the sensor suites that I need to build that I talked to you about. This is the indoor-outdoor sensor suite, and it is made of all these different things that come together to put it all together, and this is the electrical and water monitoring suite. You can see it has significantly more things inside of it, so let's go in there. This is a further breakdown showing all the different parts that come together in order to build this thing. And what we want to do is look at this. This is called a block diagram, but if we go this direction, we can actually see how all these different parts come together and what signals or properties they have that are passed between the different things. Like here's the actual computer, it has power in, it has ground, it has analog, digital, and those things all connect to this interface board that's going to be created. Now I use this to actually figure out what the custom board needs to have on it. So if we look at that, here's a block diagram of this custom board, and it consists of quite a few. It's got some LEDs on it, a resistor, 5-volt regulator, some JST connectors, and then all those things come together, and this shows how everything is actually all wired up to each other. So I did that for every different thing that needed to be built for these sensor suites. So I took all those 19 pages and I turned them into 2 simple layouts for 2 custom boards that I need to build, the last 2 boards that I need to build, and I did those in Eagle. Let me show you those real quickly. This software program is called Eagle. You can download it for free off the internet. The only thing they require is that you give them your email address so they can send you a bunch of junk mail that you can later opt out of. But hey, it's free. It's actually pretty good software. It has its pluses, it has its minuses. There are others available that you can use. I am really new at this, so this one's actually pretty simple to learn quickly. You do need to have some basic electrical understanding. If you don't, I would suggest you buy electrical or Electronics for Dummies. Great book. I have it. It's a great book. Really helps you out if you don't understand some of the basic things. But what we're looking at right now is actually converting that SysML model that I showed you. It had all those lines going all over the place into an actual electrical schematic. And we're showing all the different connectors that are on here. The computer, an LED, a resistor. We have a voltage regulator. So quite a few different things on here. And you connect all those things up. And then what you do is you hit the layout button, and it'll actually kind of lay everything out for you on a board, which is what I've done here. Now I use this to kind of keep track of everything. In the future I could actually, sorry, let me explain that some more. I use it to keep track of all the different connectors that I need to have, and I kind of do an initial layout here in computer space rather than just putting it all on the board manually. Just kind of makes sure that everything's going to work. In the future, when I get better at this, I could actually send this particular thing, this particular layout, I can actually hit, I think it's a PCB quote right here. This will actually send it in, and I can actually have a custom board built and send to me. So when we start building these more often, I could use this as a way to actually just, here's my board, pull it out of the library, send it in, get the quote, and then have them send me back some boards rather than building it myself. So it's pretty cool. Need to go from the systems model, here's how everything at the system level is going to work, and then you build an electrical schematic, and then you get to layout, and then you actually build physical things. Sometimes it's just really cool being an engineer. I know to some of you the automation stuff really isn't all that exciting, but let me tell you why it's important. We've kind of gone over it before, but for those of you that are new, this system, we want it to be able to go anywhere, and we want it to be able to go to normal everyday people. So part of that is consideration for their lifestyle. Those that own homesteads, that own ranches and farms, you know that your homestead, your farms, your ranches, all those animals, everything that you have require a lot of your attention. And anyone who ever has raised a garden, you know, you could go away for a week and come back and your garden can be destroyed if you don't have a proper watering system in place. The weeds could be a problem, too much light, too hot, whatever it is. Growing living things takes a lot of information, and we take that for granted. So we want to be able to have automation in place so that you can have your phone or a mobile device, a laptop, and you can go out for a week, you can go out for the night, you can leave your home and you can leave your system, but you can actually take it all with you right in your handheld device. In order to enable that, in order to enable, hey, my phone's telling me that I left the water on, and I want to turn it off instead of having to turn all the way back around and drive all the way back home. You can just hit a button, right? Or hey, the lights aren't working right. Do you want to do something about it? Hit a button. These plants are too dry. Do you want to add more water? I'll hit a button. Those are the types of things that we want to enable with this automation. So it's important that we get it in. Hasn't been much fun for people to watch as we put it all together. Very technical type of stuff, but we're almost done. So bear with me. These sensor suites that we have, the last two of them, the first one is for indoor-outdoor environmental monitoring. So I have some new sensors. I have a wind vane we're going to put up, and this is important. The wind vane and the anemometer, which detect wind speed, they're important to put up so we can actually start evaluating if the site is good enough for wind power, which some of you have brought up as being something we may want to consider. And another sensor that we have is a rain sensor. This one will detect the quantity of waterfall that we have per year. This one's more of a nice to have kind of unit. It doesn't directly help out the system other than I can use it to start correlating temperature, based on wind conditions, rain or sun conditions outside of the building, temperature and humidity outside the building. I can start building a mathematical model that'll show me how that impacts everything inside of the building. And we'll be able to use that for future design. Not something that normal people would ever care about, but something for an engineer who's trying to design this system. We care about that quite a bit. Want to know what's happening as far as environmentals go. So we're going to get outdoor wind, direction and speed, rain, waterfall, temperature, humidity. Those will all be part of a sensor suite. We're also going to put a thermometer down into the digester so that we can detect when the digester is working. That's a pretty big deal. As you know, we've had a problem with the digester. So this layout schematic here represents the board that we need to build so we can connect all these things to it. So that's one sensor that we need to put in, or sensor suite we need to put in. The last one we have to build two of, and that is what I call the electric and water monitoring system. So this particular board is going to connect to a few different sensors for really actually quite important reasons. One day I was out this last summer after we just got the system built, and I came into the house and I realized I left the water running in one of the fish tanks. And I jumped up and I sprinted out to the building, and it had been running for a few hours. And I got there just in time. The water was just starting to come up over the top of the pond liners, which then would seep into the ground, and that could have led to a disaster. If that water gets into the ground around it, it could destroy the integrity of the dirt, which is holding up the grow lanes. Literally everything could have just been destroyed. We never want that to happen again. So we're going to put in a valve so that when we're away, if we forget that the water's going, we can just hit the button and turn the valve off so the water stops. We're going to put a flow sensor in so that in order to let us know that we forgot the water's running, there'll be a flow sensor that can detect the flow of water, and some software will be written that says, hey, if you as Jeff are not inside the building for more than, let's say, 5 minutes at a time, we're going to give a warning that says the water is running, and then if you're still not there and you haven't cleared the warning, we're going to turn the water off so that you can't have that situation occur that happened to me this last summer. That's actually a safety critical thing. Even if I had different shelving, I would still want this because we don't want water running all over the floor. It would destroy anything that we build. So putting in that valve and the flow sensor are going to be very important. Evaporation is another key thing that is a concern. So to help with that, actually that's the only way we really lose water out of the system. Every now and then we're going to have to put more water in. And what I want to be able to do is, again, while we're away, if you have some really, really hot days and you have a lot of evaporation, we want to be able to detect the water level and see how it's doing. So what I have here, this is a fairly inexpensive sensor. This is an ultrasonic distance measuring unit. It just sends out a sound wave, and it, you know, bing, bing, type of thing. If you ever watch Hunt for Red October, this is like sending out a ping. Crimson Tide, any submarine movie. Which one do you like better? It's got to be Hunt for Red October, right? So we're going to put this in so we can actually detect the water level in the fish tanks and be able to, again, when we're away, you can see what the water level is like, and if it gets too low, if there's a lot of evaporation, maybe it's 110 degrees outside and you got lots of evaporation, we can take this sensor, it'll tell us where the water level's at, we can hit the button that says add more water, then we have a valve that's in there, we have the flow sensor, it adds more water, measures how high it is, and turns it off at the right time. Again, you'll be able to do all this away from your unit, so you don't have to be here the whole time watching the water fill up, right? You could be sitting in a movie theater and do it. You could be sitting at a coffee shop having coffee with your buddies. You could be at a bar. I don't know if operating the system while intoxicated would be a great idea, but it could be exciting, so we better put some safety measures in there in the code so that someone can't go drink too many beers and leave the water running. Anyway, so that's one part of this sensor suite that we're going to put in. Another part, we are looking at redoing the microgreen watering, and you're going to see that in another video, but kind of already going ahead here, I'm going to put in a relay. That's a switch, an electronic switch, to turn the microgreen watering system on and off. So we're going to put that in place. We also need more fan flow, more airflow in the building. Fan flow doesn't make any sense. So I'm going to put in place a relay, another switch for fans, so that they can be turned on and off. If you followed along, you know we already have one out there. I'm going to redo all that so that it's connected here on this lane. So this sensor suite that we have, again, this one here, I got it all put together in Eagle, and we're ready to build both these boards. This is going to go at the very end of the grow lane, so each grow lane will have its own individual control unit here. We'll be able to turn on the fans, we'll be able to turn on the water to fill the tank, we'll be able to, oh, the last one I have. Thank you to the subscriber who told me about this little guy right here. This is a power monitoring unit, and it's one that actually has an output on it, there it is right here, that I can send to the Arduino and actually record our power usage. And this is hugely important to me. You can calculate all day long what type of energy needs you have, power, how much power we're going to use. But until you can actually measure it and see what the actual devices are doing and how everything's being used, you really, really just don't know. So this particular unit will connect into the power line on each grow lane, and we'll be able to see how much power we're actually consuming. So I'm very excited to start putting these in place. This is the first time I'll use this. It'll tell us how much power we're using, voltage, amperage. Very excited to get this one in, and we'll be able to measure that with this device as well. So that's kind of an overview of these last set of sensors. I just got to get them all in, and then we got to start writing some software to actually control everything and monitor it all. So I'm excited about that. And once these sensors are done, we're into summertime build projects. So we're going to have to do some design there. I look forward to sharing that with you, and actually start building some things, welding, doing mechanical things that a lot of you will find a lot more interesting. So sorry this is taking so long to get through the automation. As you know, it's just me doing all this, so it takes a while to get there. So I'm going to get going on this. I'll do another video and show you the update, but just wanted to give you a quick overview of what we're doing, and you'll see it all be put in place here in the next few days. Thanks for following along, everyone. If you like this video, be sure to give us a thumbs up, hit subscribe if you like, and the notification bell there will notify you when we put new ones up. If you have a problem, we are on Facebook or Twitter. You can join us there and you'll always be notified of our new videos. In the meantime, everyone, this is The Real Martian. Out.